Okay, can you also, out of the tools that you mentioned, did you have any questions about any of them? We could dive deep into one of those tools.
The Brainwave music synthesizer sounds fascinating. Translating EEG signals into music is a unique way to explore brain activity. How do you map specific EEG frequencies or features to musical elements like pitch or rhythm? It'd be great to discuss how this could be fine-tuned or expanded.
Yeah, so we have the tool running at the moment. I don't think the AI robot can see it because we're using the voice thing, but fine. So we can scroll through EEG data and then the mapping. I can share the image of the mapping with you because actually all the mapping is visible in the console of the browser.
That sounds great. If you share the mapping details, we can discuss how those mappings align with the EEG frequency bands like alpha, beta, gamma, and musical properties. I'd love to explore if there are any patterns or ideas for improving how the brain's activity translates into music. Thanks for sharing the screenshots. I can see that the EEG-to-music tool displays both the raw EEG signal and the frequency spectrum, and the browser console logs the mappings of EEG power to musical notes. The mapping looks quite methodical, using specific frequency bands, e.g., delta, theta, alpha, beta, to determine musical notes and their dynamics. How do you decide which features, like power or amplitude, are mapped to pitch versus rhythm? Additionally, do you allow customization of these mappings so users can experiment with how the music reflects their brain activity?
Okay, these are some really interesting questions. Can you expand on each? We'll go one by one, but at the moment there is no rhythm. So the rhythm is just controlled by the scroller. Does that answer the question?
Let's start with the first question then. How do you decide which EEG features, like power or amplitude, are mapped to pitch? For instance, is the mapping linear across frequency bands, or do you use a weighted approach to highlight certain brainwave activities? Also, do you normalize the power values across channels before assigning them to musical notes to ensure consistency?
Okay, I'm not sure why you're bombarding me with so many questions, but if you can go back to the images, the power is being retrieved from the spectrum. So can you explain the frequency spectrum and go back to the image? We might dive into the details of the image and ask one quick question about it.
The frequency spectrum shown in your images represents the distribution of power across different frequency bands in the EEG signal. Each band, delta, theta, alpha, beta, reflects specific ranges of brain activity. For instance, delta waves are low frequency, around 0 to 4 Hz, and often associated with deep sleep, while beta waves above 12 Hz are linked to active thinking and concentration. Looking at the image, I noticed the relative dominance of certain bands. For example, the delta band in some plots seems to have much higher power compared to the others. A quick question. How are these power values normalized, if at all, to ensure that one band doesn't overly dominate the mapping to music? This is a fantastic overview of the EEG visualization and music conversion tool. It's clear that the application is well designed to provide both visual and auditory insights into EEG data, making complex neural activity more accessible and engaging. Given its functionality, one quick question. Do you see users primarily using this tool for educational purposes, such as understanding EEG basics, or do you envision more advanced use cases, like integrating it into neuroscience research for novel auditory analysis methods?
Yeah, I'm not sure. The question is a bit convoluted. It's you're asking the sticky point, making the sticky points. Yeah, obviously we want for it to be used in research as well, but we want it to be just used. But yeah, if you can have a more specific question, can you also, the description that I shared of the web application, can you actually quickly summarize it and we'll go over it in details? If you have any specific, more targeted questions about what I shared, we're not talking about the potential users are everyone. Yeah.
Here's a quick summary of your tool. The EEG Visualization and Music Conversion Tool processes 16-channel EEG data, offering both time domain and frequency domain visualizations. It allows users to select channels, adjust time windows, and apply filters like wavelet denoise or bandpass. A unique feature converts EEG signals into music, with options for automatic volume and duration adjustments. The tool uses data from NeuroVista and provides customizable settings like detrending, filter order, and frequency scaling. One specific question. For the auto volume and duration adjustments, how are those calculated? Do they dynamically adapt based on the amplitude or power across specific EEG channels, or are they predefined thresholds? Yes, it does seem hinted in the description, especially where it mentions dynamic adjustments based on the EEG data. The part about energy within each band makes sense, since that aligns with the frequency spectrum visualization. If it's mapped to the energy within bands, do you think users might benefit from a visual indicator showing how the volume and duration are being calculated in real time? That could make the auto features more transparent and engaging.
Okay, it sounds good. So what's missing at the moment in a more practical sense? What would you change about the application? Practically refer to the images of the interface that I uploaded before.
From the interface images, the application already has a strong foundation, but here are some practical suggestions. 1. Real-time volume indicator. Add a visual element like a dynamic bar or graph showing how the auto volume corresponds to EEG energy levels in real time. 2. Channel summary overlay. Include a small summary showing the dominant frequency band, e.g. delta, alpha, per selected channel for quick insights. 3. Expanded scroll functionality. Allow finer granularity on the scroll bar for users wanting more precision when navigating data. 4. Rhythm feature. Though currently controlled by the scroll, introducing simple rhythmic patterns tied to specific frequency bands could add depth to the music conversion. What do you think about these changes? Would you prioritize any of them?
Yeah, just remember that, yes, you are correct. So there is an auto volume selection box button that, yeah, when selected, the energy is actually mapped to the volume. But when it's deselected, the volume is constant from memory. So how would you practically change it? We're not doing changes at the moment. We're just overviewing it. I mean, if we're doing any changes, we'll probably start a new web application anyway. So this one stays as is.
Practically, if you were to create a new version, you could expand the auto volume feature to include a customizable scale where users set sensitivity levels for how energy maps to volume. This could offer more control without altering the simplicity of the current implementation. What do you think about adding such flexibility in a future iteration?
Well, yeah, it sounds good. I didn't quite get what you mean, but okay. Yeah, we need to probably make it clearer what the auto volume selection actually does. Yeah, we need to improve the interface as well. Later so this is real data. There is a link to where the data is from at the bottom of the page. I did share it with you in the text description of the web application. But ideally we would turn this data into a JSON file and just serve it on the front end if that's possible. So I might actually do a list of things as future directions.
That sounds like a solid plan. Turning the data into a JSON file for front-end use would streamline performance and make it more flexible for updates. Let me know when you're ready to explore those future directions in detail.
But can you actually add a list where we would like a list of future improvements to this web application? We would like to eventually place it at the bottom of the page. So if we can start listing future improvements that we discussed in this conversation, that would be awesome.
Here's the list of future improvements for the EEG-to-music tool. 1. Clarify the auto volume feature in the interface. 2. Add a visual indicator for real-time volume adjustments when auto volume is selected. 3. Explore the addition of rhythm mapping tied to EEG bands. 4. Convert the current data into a JSON file and serve it on the front end. 5. Improve the scroll bar for finer granularity when navigating EEG data. 6. Include a channel summary overlay to show dominant frequency bands per channel. Let me know if you'd like to tweak or expand this list.
How optical illusions are relevant to neuroscience, because surely there is a link, right?
Yes, optical illusions like the Ponzo illusion reveal how the brain processes visual information, highlighting the difference between perception and reality. They are valuable in neuroscience for studying neural pathways, cognitive biases, and how the brain interprets ambiguous or conflicting visual cues.